Hello and welcome back to this video tutorial on how to factor polynomials. Where we left off was that we were trying to factor a quadratic polynomial with a non-1 and a negative a value. So what we were doing is that we found the master product, which is a multiplied by c, that coefficients a multiplied by c, and now we are trying to find factors of 36 that will add up to give us 15, which is the middle term. And from there on, we can split the middle and factor this polynomial. So, as we have listed out all the factors of 36, let us take a look at them. So 6 times 6, that adds up to give us 12, so that will not do. 4, 9, that gives us 13, that won't do either. 3 and 12 works. 2 and 18, 20. 1 and 36, 37. Alright, so now that we have the two factors of the c value, we can now split the middle. So we are going to do the exact same thing as we did with the last example. We are going to split 15x into 3x plus 12x. Minus 4. Alright, and now we do the same thing as we did last time. Oh, and a slight note at this point, it doesn't matter in what order in which you put in what way you group your the two middle terms. As long as you group them together and you start to factor them, you should end up with the same results. Alright, so let's group them this way. You could group them negative 9x plus 12. That is an option, and you'll end up with the same results. You can try it yourself if you would like to. So let's factor negative 9x squared plus 3x. So taking a look at this, we can see that we can take out a variable x, and we can also take out 3. And in this case, let's try to take out the negative sign. So what we have is negative 3x. And what would be left inside the parentheses is 3x minus 1. And then when we do the same thing, the 12x minus 4, we take out the 4 to factor it, and we end up with 3x minus 1. Now once again, we can factor this entire thing by taking out negative 3x plus 4 and grouping them into another binomial. Due to the distributive property, we can do this. It's altogether fitting and proper that we should do this. And there we go. We have factored a quadratic polynomial with a non-1 a value. Alright. A note about when you do receive a negative b value. In that case, things get slightly more complicated, but you are still applying the same method, except you should double in the amount of variables you sorry, I misspoke. If your master product comes out as negative, for example, negative 36, it gets a bit more complicated because you would have to look for variables that would still be looking for variables that would add up to the middle to the coefficient of b. However, things get slightly more complicated as you have to take into account both positive and negative factors. For example, if the master product was negative 36, you would have to look for negative 6 times 6, negative 4 times 9, blah blah blah. However, you would also have to go in the other direction and take negative 9 times 4, which is a conjugate of that. So you would have to consider both directions if the master product does turn out to be negative. Alright, so I think that we are done with this form. Now we are going to take a look at the next form, which is the difference of two perfect squares. A squared x squared minus b squared y squared. And if you remember from the expanding polynomials video, this is the form x minus y times x plus y, which gave us x squared minus y squared. Alright, so now in applying this pattern to 9x squared, our example 9x squared minus 4y squared, we basically plug things in and we basically factor them and produce these two binomials. So 9x squared is a squared x squared. So we can see that a squared is 9. So then a would be 3 or negative 3, but we shall not bother with that right now. And b squared is 4, so we'll take b to be 2. So what we would have is 3x minus 2y multiplied by 3x plus 2y. Now, while this does look like the first form that we looked at with the x plus y in parentheses squared, the reason why this becomes the difference of two perfect squares is that we would have when you're expanding the polynomial, you would have plus xy minus xy, and that's why it cancels out, and all that you're left with is x squared minus y squared. Otherwise, it is the exact same as the other rule. So there we have it. We have factored the difference of two perfect squares. This is another rule that you should remember, and it should help you a lot when you are dealing with it is quite a common polynomial to encounter, and by knowing this rule you should be able to factor things extremely quickly. Now let's take a look at another form that should say a negative. We are not going to deal with positives because that would mean that the b squared value would have to be negative, which means the value that we would end up with is imaginary, and we're not going to deal with that right now. So what we have here is 131x squared minus 144y squared. So once you memorize the form, this should come extremely quickly. That would give us 11x minus 12y multiplied by 11x plus 12y. Alright, Um,